right, so thank you, Lauren, for telling us that we were not recording. So anyway, I appreciate that. So Eden, our star pupil, she had a great question, a little confused about burning combustion, okay? And I said that this is ethanol, and you combine it with oxygen. We're assuming complete combustion. It's amazing how I can almost use the exact same words, isn't it? After doing this for 37 years, it becomes rather...
Scripted?
Scripted. She was very deadpan when she said that. Did you notice? Okay, so this is called combustion. When you take a hydrocarbon, you combine it with oxygen, and you produce carbon dioxide and water. Respiration is similar to this. Burning wood, paper, gasoline. And you balance it, always balance that last. You put a 2 there, you put a 3 there, because we have 5, and we have 5 and 1 is 6. And then you have 7, and then you have 1 here, and then you need 3 there, okay? So balance the oxygen last, okay? So this is the problem. Let me read the problem. It says, calculate the enthalpy of combustion of ethanol from the following data. Assume all the heat of the reaction is absorbed by the water. Compare your value with the IB data booklet value and suggest reasons for any differences. Okay, here's the data. Remember, we're using a calorimeter, measures heat changes, and the amount of water is 200 grams. The temperature change is 13 degrees Celsius, and the amount of ethanol, ETH, is an abbreviation that I use. You'll see it all the time. It's a rather standard abbreviation for ethanol. Ethyl alcohol, OH, as it means it's alcohol, is 0.45 grams. Okay. Now, what's the first thing I do? What's the first thing I'm going to do? What is the first thing I'm going to do? You know, I don't even want to look at the solution. Let's just do it ourselves. So don't you have to measure, okay, well, I burn this much, this water, that amount of water rose that many degrees, correct? So I know that it's going to be mass delta T times CP for the water, correct? So if I know how much heat evolved, I know how much that ethanol gave off. So let's do that. So what is 200 times 13 times 4.18? Bushes.
10,862.
What'd you say? 11,000? 10,000? 868 joules. Are you okay with that? Everybody okay with that? Yes? Okay, so when I do the molar, sorry, I gave it away. But when I do the enthalpy of combustion, it's going to be the molar enthalpy of combustion. So change this to moles. How do you change that to moles? Can I erase this? We don't need any more, right? Okay. So 0.45 grams moles equals mass over gram molecular weight, right? And that's going to be, what is C2H5OH? C2H5OH. So that's going to be 6, 16, 24. Is that right? Am I looking at that right? You have 6 hydrogens. You have 1 oxygen and 2 carbons, yes? So what do we got?
46.46.
Just use mass numbers. Don't go too crazy. What do you got?
46.
Oh, you said 46? Sorry. I'm sorry. 46 AMUs. Right? So divide this by 46. And what do you get? What do you get? 0.45 divided by 46.
0.00, 0.010.
0.012 moles, right? Is that right? That's wrong.
010. Oh, 0.6. Because it says 0.00978.
Okay, can we like come to an agreement, do you think? What do you think? I know that it's like Friday morning. Can we come to an agreement on what the value is, do you think? What do you think? It's going to be about 1 something because it's almost 0.45 over 46. So what is it going to be? Can you help us out here, Professor Munkle?
0.01.
0.01?
Yeah.
Is that what you said?
Yeah.
Where'd you get 0.012?
I said 0.010, but 0.01 is.
You didn't say 0.012?
She said 0.010.
Did she say 2?
No.
No? So it's me. Okay. I'm starting to hear things. Okay, that makes sense. Is that okay? Okay. And how come you didn't say anything there, Professor, when it said 0.012? I thought that was a little bit, yeah, so I'm hearing things. That's okay. It's wax, I'm sure. Old men get wax in their ears. Okay, so that's that many moles. Okay, yes? Right? Right now. So, if I get 10,868, can we say that's kilojoules? How many kilojoules is that? Can we just round? Can we just round, please? Put us out of our misery. Can we just round this? Isn't this 11 kilojoules? Isn't it? Can we say that, please? Is that okay? Is that all right?
Yep.
Yeah. Over 0.01 moles. So what is going to be the molar heat of combustion? Use proportional relationships. So it's going to be over 1, right? 1 mole, right? So what's 11 times 1 divided by 0.01?
1100.
What is it? You guys have calculators on your desk. If you don't feel like guessing, which is fine, no problem. No problem with that at all. None. What do we got? So what's 11 divided by 0.01?
1101. 11 divided by 0.
Is what? Is what?
Oh,
Eden, they're just allowing you to do whatever you want here.
It says 1100. 11 divided by 0.11.
Yeah, you're just, it's divided by 100th, right? So it's going to move the decimal point over, so it's 1100, right? Right or not? Okay, so it's going to be 1100 kilojoules per mole. What's the answer? Did we do this right?
The book's answer is negative.
Oh, I got it right. Wasn't that good? We got it right. But Lauren pointed out something very, 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 very curious.
The book's answer is negative.
Because you know why it's curious? Because they said, look what they said. They said that the temperature increase was 13. Was 13. Right? Right? Said it was 13. Right? But, so what do you have to do? Now, we're not done yet, but that's our correct value. That's our correct value. But what do you have to do before you can finally report it? Anybody? Now remember, it's always the object that we're looking at versus the environment. Right? Yes? Okay. What happened to the environment? The object was the ethanol. What happened to the environment?
It absorbed the heat.
It absorbed the heat, right, which means from the perspective of the ethanol, what happened? Now listen carefully to my English. Was the reaction of the ethanol, was this reaction is that on the screen?
A little to the right.
Was this reaction that reaction? Let's balance it. So I'm going to put a 2 here, I'm going to put a 3 here, I'm going to put a 3 here. Is that balanced now? Was that reaction 1 mole? Doesn't that say 1 mole? Yes? 1 mole of ethanol. 1 mole of ethanol will give you that many kilojoules, correct? Is that reaction? Well, let's see. Did it give off energy or did it absorb energy? Let's see.
Endothermic.
What is it?
Endothermic.
It's endothermic.
Yes, it is.
Did the water warm up or cool off?
Warm up.
Where did it get the energy from?
The ethanol combustion.
So was the ethanol, was the reaction exothermic or endothermic?
Exothermic. Yeah.
It was exothermic. In other words, here's my reactants. Here are my products. Correct? This is enthalpy. This is time. It's always final minus initial. So it's going to be, the change in enthalpy is going to be the enthalpy final minus the enthalpy initial. And in this case, this is higher than this. This is higher, right? So it'll be negative delta H. So is this value negative or positive? It's positive. Isn't it like this? Didn't it give off energy? So if it gave off energy, shouldn't it have a negative sign? You got to interpret the results. You got to interpret the results. Well, how do you know it gave off energy? Well, the water rose, it changed temperature, it heated up. Ethanol is a hydrocarbon. One of the basic concepts of a combustion reaction is that it gives off energy. Respiration gives off energy. When wood burns, is it really, really, really cold? If I burn wood and I put my hand on it, burning, do I get frostburn? Do I get a frostbite?
No.
If I, in a really hot Phnom Penh summer, should I get a stove, put it by the fireplace, put a lot of wood in there, burn it, will that cool the apartment down?
No.
So then you know what combustion reactions are, don't you? You know what burning wood does. You know what burning ethanol does. What do they put in gasoline nowadays? What additive, especially in the United States?
Ethanol?
They put ethanol. They put ethanol. That's why cereals are so expensive, because a lot of the land is used for corn to make ethanol. It's really weird.
To be fair, at least they took the lead out of the gasoline, so it could be worse.
Could be worse. They could actually put money into alternate forms of energy. Could be worse, could be better. But anyway, but true. So you know what a combustion reaction is and does. So that's, it's more than just solving problems. You have to interpret the results. You have to know what's going on. Yes? Yes or no? You're always going to have a lab to do lab work in? No, I mean, you got to be able to look at experimental results and understand what's going on based on the observations that are made by the chemist in the experimental paper, right? Yes or no? We're off.